And if you're looking for your agenda while you're waiting, pull up meeting 2. If you want to be in the rats room, you are in the right place. If you don't, now's the time to go find your room. Okay, we're right at 2:30, so why don't we get going? Ned, do you want to pull up the chair slides, please?
Should be just, I think they're displaying. Let me know if that's not the case.
Oh, yes, they are. I'm sorry. So if you would like to
Right.
advance, I'll just go through the note well quickly. This is the note well and all of the documents that are required for review for your participation. The note well applies to every IETF forum, from this in-person meeting to your contributions online and through Git and other like design team collaborations and so forth. So please pay attention and understand the note well. Next slide, please. Code of conduct. Hopefully at this point in the week, I personally haven't seen any bad behavior that required being called out specifically, but when we give feedback, we give it in a neutral way. We're not attacking people. We are helping them improve their work, right? And to make good decisions. And so please keep that in mind with the code of conduct. All right, next slide. I'm going to go through the introduction. Michael, if you want to post your slides, please do so.
I just wanted to say I thought I was removed from the agenda because of time.
Oh, Ned said we're looking for it. So
I thought that last week you said there was no time, and I said remove me from the agenda.
Okay, so
I mean, I can, if you have time, I can come up with slides in the next 10 minutes because I already have them. But that's what I thought.
All right, we also have Osama that's itching to present.
We shaved off a few minutes from a couple of talks, so we might have time.
All right.
Is there time allocated for Michael though, Ned?
Yeah, he's got
Okay.
10 minutes for proof of position.
I'll get them proposed to you in 10 minutes. And when you said no one's done anything yet, that sounded like a challenge to me, but the code of conduct, I know that's not what you intended.
All right, well, maybe I've been in the nice sessions. Okay, volunteers. Do we have volunteers for note takers? Yogesh, Osama, thank you both.
And also Mike volunteered.
Great, thank you, Mike. All right, next slide, please. All right, so these are just some helpful links for the sessions. Next slide, please. And our agenda is absolutely packed, so we're going to be really careful on time today. And with that, we have Thomas for our first presentation on conceptual message wrapper. Thank you, Ned.
Hello. Cool. Conceptual message wrappers. Next, please, Ned. So we had the third working group plus call in early May. Got a lot of reviews. We have worked in the meantime to address all the comments, and we published 16 on the 3rd of July. We had, I think, a few other intermediate drops in the meantime, because we had to do adjustments, but 16 is the one that we think addresses, I would say, all of the comments, but one, which we can then discuss. Next, please. So, changes. We have rewritten the abstract to make it more, rich in information and clear. And this was Anna's doing that work. We had Carl suggesting that we should have a separate section to describe what a CM type is, which we did. There is now a new 311 section with description, CDDL, and a pointer into the registration machinery that we are creating with Diana in order to register new conceptual message types as they come. Lauren suggested we explain what within the CMW collection and the CMWC type is. And in fact, not only suggested that, but he also provided the actual text. So we have a new paragraph with a clear explanation of what that claim is. Carl suggested that what is that? Comment. Oh, okay, it's a typo. Sorry. Carl suggested that we commented the max function with specific comments per each entry. In the case, we did it. Next, please. And then here, this is the thing that is more, it's a bit wobbly still. Usama requested a clarification on section 4. When we say section 4 is where we define all the envelopes, right? The signature envelopes that we support, sign 1 and the X509, blah, blah, blah. And we had this very, very thin sentence at the beginning that said, this section highlights a number of mechanisms to add cryptographic protection to CMWs. And Usama wanted us to unpack protection. So in 16, we have this new paragraph that says what we mean by protection, authentication, integrity, and if used with challenge response protocol, anti-replay. But we're still debating this. So Usama is uncomfortable with the use of authentication in that context. So we tried another iteration. Jonas suggested the text that is the newer is still in a PR. We have not yet merged that, where we actually say, we identify a bit better who the subject and the object of that sentence is. So we're talking about protocol designers, and we are saying that they can obtain those properties when they use, where they employ the CMWs within their protocols. And we also have the last sentence that says, but anyway, you need to carefully evaluate those properties in the context of the security model of your protocol. We're still debating on this. I suppose Usama has something to say.
Yes, for sure. Thank you very much first for changing that, clarifying what these protections are. It's always unclear to me when the word protection is used. It can be interpreted in many, many ways and so on. So it's really important always, not only for this draft, for every draft in the RETs, I would really like to understand what the draft actually provides. And particularly in this case, because I'm using this, or actually we are actually using this in attested TLS, I really need to understand what CMW can provide and what do I add on top of that. And the main concern that I have with this, let's say in new 16 was, it's saying authentication. If it already provides, if CMW with all these mechanisms, let's say already provides authentication, why are we talking about attested TLS? So my understanding is that authentication is provided by the protocol, but the state is provided by attestation. And that's where the two can be composed. We need identity for sure. We don't want to, let's say, go against what IAB is saying in their statement. We surely need authentication, but at the same time, we need the state of the machine. And there my concern was that if CMW already, or if you, let's say, as one of the author already claimed that authentication is provided already by CMW by some means, why do we talk about attested TLS at all? And more particularly, we agreed on the list in a discussion with Lawrence, and we said that we will never use the word authentication stand alone without a qualifier what that authentication actually is. So I am really against using authentication at all. My simple proposal was drop authentication from this statement. I'm perfectly fine with integrity, challenge response, and other things which are there. So if you just remove the word authentication, I am perfectly fine with it. We can just proceed with everything. Otherwise, if you want to still have authentication, I see that you in the follow-up on the PR, there is comment by Yonat, which is saying this is kind of not the entity authentication, but rather some other kind of authentication.
Data origin.
Sure, please add that as a qualifier so that would
That would
most
clear-
likely be fine for me.
Okay, because I was to suggest authenticity.
I mean, at least there should be some qualifier that it's not entity authentication, which is
Instead of dropping completely authentication, replace it with authenticity.
that I have to think about. Like, I mean, authenticity in what sense?
In the sense that the signer of the thing. Well, this is the contention, right? So we need to solve this, Yogesh. We cannot go past this. This
Yeah, I mean-
this is the point of contention.
If the chairs want, of course, I have no concern on doing it on the list. If
So,
that's
okay,
up
so
to
we
the
have,
chairs.
we have two ways. One, which is safe, add data origin and qualify authentication with data origin authentication.
Right.
So-
I still have.
Can we agree to have the conversation offline and resolve it? It seems like there is something here. We were going back and forth, so maybe we can resolve that conversation and bring it back to the list.
Okay, cool, no problem. Next, please. And then the rest of the updates. An embarrassing error in the CTI claim, which is noted by Carl and fixed. We now use 35, the allocated code point for EDP CMW, which is great. Thank you, Russ, for registering, helping out with the registration and suggesting that we actually use that. Mike, I think he contributed the privacy consideration section to the draft, which is great. And then we had a reflow of the security considerations to address a few of the comments that Usama raised about awkwardness of the flow and stuff like that. But next, please. That's it. Okay. So we have a few updates on the running code side. We have updated the Golang implementation to match the latest version, but the great news here is that Jonas, who's our splendid shepherd, also provided a Rust implementation of the latest. So we now have two implementations that interoperate, and there has been also some work in Keylime to add CMW to wrap TPM evidence. So we are seeing some adoption also outside Verizon, which is great. Next, please. We're ready to ship modulo this fix that we will negotiate with Usama on the list or here. Given we are here, we can do that shortly. Okay? Questions? No? Good.
No questions?
Sorry, Ned. I can't.
Okay.
I think I'm
We
going
move to the next topic
right.
then?
Yeah.
Okay.
Yes.
Okay, eat measured component with Thomas again.
Again, thank you. Ned, okay, cool. Quick recap, what is this thing? This extends the EAT measurements claim with a new payload, new data item. So it comes with pre-provisioned with crossword as the EAT measurement. We are adding a new thing to the toolbox, which is a measure component, which is a very, very simple object that captures a measurement, a single measurement with some of the relevant metadata associated with that. A few examples: firmware component, RTIC, a file, CPU register, really. Any of these could end up in one of these measure components. Next, please. The changes since Bangkok is that we decided not to go ahead with SVN as one of the possible measurement types because there was no interest. We tried to pull the thing a couple of times, but it was dropped on the floor. And the important thing is that we added the support for raw values alongside the digested type that we already have. So we now have the ability to also stash raw things in there, which supports a few interesting use cases. For example, when you have to remap SPDM into it. We think that now we are feature complete, and for that reason, we would request a working group plus call if possible. Next, please. I think that's a slide with a request for working group. Yes. Yeah, I think the draft is in reasonable shape. Also, is readable, is simple, and yeah, please provide reviews.
Okay, great. Thank you. I know we've had other people volunteer to do shepherding. So if anyone wants to be mentored in that, send Ned and I a message.
Good point.
Thank you very much, Thomas. Next up, and I hope I pronounced your name correctly, Yuzhong Song for remote attestation over ad hoc.
Sorry, Kathleen, just a clarification question. What was the action for the last draft?
I was soliciting for people who were interested to learn to be a shepherd, a document shepherd.
Okay, thank you.
Okay, so start? Yeah. Thank you. So hi, I'm Yushan from INRA Paris. So today is about the draft remote attestation over ad hoc, which is a draft that was adopted earlier this year by Lake Working Group. So today, I think the presentation is more like informational to let REST community know that there's also ongoing attestation work that is at Lake Working Group. And also, of course, the more reviewers, the better. And also, we learned a lot from the attested TLS people. So many thanks to them for helping and giving the advice during the time. Yeah, so next slide, please. Okay, so first, why we need it. This draft is designed for IoT scenarios. So the use cases are like IoT devices onboarding and also any scenarios that need a fast and early trust establishment. So for example, when IoT devices are moving and when they need to connect to a new gateway, then how could we perform a fast attestation to connect with the new gateway without interrupting the operations. And of course, the solution is our draft, which we specifies how to perform attestation by using ad hoc EAD fields. And it's based on REST architecture. And right now we support both background check model and principal model. And also in the draft, we specifies how to perform unilateral attestation and mutual attestation. Next slide, please. Okay, so first, why ad hoc? Why we perform attestation over ad hoc protocol? So ad hoc is it became an RFC or I don't know if yeah, Usama. Okay, yeah.
It's fine. If you want to take it later on, it's fine for me.
Okay, fine. Maybe after this slide. Yeah. Yeah. So ad hoc became an RFC last year, and it's a lightweight authenticated key exchange protocol, which also designed for IoT use cases. And here we have ad hoc initiator and responder, which are the two parties. And of course, after the three-way handshake, they have the derived keys. And I will not go to more details about it because it's for authentication. What I want you to look at is the EAD fields in each message. Yeah, so next slide, please. So for EAD, it's external authorization data, which ad hoc allows some external security applications to be integrated into ad hoc. And also we can define the separate specification to say what we want to process in the EAD field. So for example, the draft that I'm presenting now, we define how to perform attestation in EAD, and we also have other ongoing work, like another draft describing how to have the authorization over the ad hoc. So I forgot to mention, but yeah, ad hoc has also an optional force message. So in total, we have 4 dedicated fields for EAD, EAD 1, 2, 3, 4, and each EAD field is composed of 1 or more EAD items, and each EAD item is EAD label with an optional EAD value. So maybe Usama, if you have the question.
Right, so it's related to the very first slide. So when you say motivation, you have the IoT device onboarding.
Yep.
I'm trying to understand how would remote attestation in this case would be helpful.
Okay, so imagine the most common case when an IoT device want to join a network.
Yeah.
So before we start the session, like before the session setup, you want to make sure that this device can be trusted, like this device is reliable. So in this case, we need to perform the attestation before we allow the device to join into the network. So this is a most common use case for attestation.
Right. But, I wouldn't say like the most common use case, but most common use case in IoT, for example, maybe.
Yeah, of course. Yeah, because we are
server is the
target.
most common use case.
Yeah.
Okay.
Sure.
So if you do this kind of remote attestation for IoT, more specifically, I would like to understand a practical use case. So what would you say? So probably there was a misunderstanding on the discussion that we had. I glimpsed at the email response. I have to look into it much deeper.
Yeah.
But could you say like what is the real kind of use case, more realistic world use case that is basically driving this kind of work? Like IoT, where would I, or one maybe real life example to kind of show me that this is really required, for instance?
Yeah, of course. And just to clarify first, like the comments you sent in the email is not relevant to the draft. I replied to you also in the email. You can check it later. Okay, so a real use case. So recently, we also have a reviewer from Orange, which is a company in France for telecom operators. So she told me that one of the use case could use for smart cities, smart home. So when you have the new IoT device that wants to connect to their live box, then they need to perform an initial attestation in this case. So that's one of the real cases that I know from their company. But for more use cases, maybe I need to looking for that.
Sure.
Yeah.
I mean, one is sufficient if you can add that with a reference to their use case. So that would be fine.
Yeah,
Thanks.
I will try to add this in my draft for the motivation part. Yeah. Thank you. Where are we? Okay, so I said, the EAT item it has EAD label and optional EAT value. So yeah, next slide, please. Okay, so this is a message flow that we have for the attestation in background check model, and different with the attested TLS, where they have usually the server as an attester. In our case, we mostly have the IoT device as an attester, like what I said, the use case before with Usama. So here for the background check model message flow, we have the IoT device initiates the attestation operation with an attestation propose item, which has a list of the evidence tabs that is supported, and we simplify it as only a list of integers that is already registered under the IANA registry. And then we have the EAD tool that carries an attestation request EAD item that it is composed of the selected evidence type by the verifier and a random nonce generated by the verifier. And for EAD3, we carry the evidence, which is formatted as an EAT token. And I know that EAT this year has just become an RFC, so very happy to see that happen. So yeah, that's the general overview of what we have. So if you are curious about more details of the composition of the EAD items, you can look at the draft. So next slide, please. Okay, so here is the mutual attestation, where we combine the background check model and the passport model. So what is the same is that when the LT device is the attester, we are still performing in the background check model. So the blue color that you see is the same as the previous slide. And what is new here is that we add the passport model for the case when the network service is the attester. And the color in red is the EAT items that is relevant to the passport model, where we have firstly a trigger PP that we allow the LT device to initiate to signal the network service to start an attestation in passport model. And then we have the request, result proposal and result request in the following EAD fields, which is for the LT device to select the trusted verifier that it wants the attestation result from. And then we put the attestation result in EAD4, which we use the ad hoc message for. Yeah, so that's the mutual attestation we define in the draft. And next slide, please. Okay, so for the features of our draft, or I can say it's the difference between our draft and attest ATOS. So for example, we are both for intra handshake attestation, but what is different is that firstly, our draft, we don't need to modify ad hoc protocol to support the attestation operations, because as I said, we perform the attestation in EAD, which is supported by ad hoc for external storage data. Yeah, so that's one point that is quite a huge difference. And then also the next one is actually based on the ad hoc feature. So we do not put any requirements for the underlying layers. So unless attest ATOS that depend on like UDP or TCP. So for us, we don't depend on any network layers. And also, as we are targeted for LT devices, so of course, we need small message sizes and low energy consumption. So the figure I put here is one of the results from our implementation where we performed the attestation in the background check model. So just like say in the LT scenarios, as you see in average, we only have 16 milliamps during the operation, which is quite low. That's used for the LT devices. And here the total time is like 5.5 seconds, but it's because we are using pure software crypto backend, which of course takes more time for hashing or signing operations. And if we use the if we add hardware acceleration, then this attestation operations can finish less than half second. Yeah. Yeah, so that's I think that's all. Maybe next slide, please. Yeah, so yeah, that's all for my presentations. Yeah, and if you have any questions, welcome.
Great, and we'll keep the questions quick just to stay on schedule. Thank you.
Okay, sure. So just a quick one. So we moved on to, for a tested TLS, on to post handshake, and I would suggest that we then discuss afterwards about also what's the lifetime and so on, and if ad hoc should also move to post handshake.
I think you mentioned that also in the comments from your email. I think I have some short answers, and if you want to discuss more, of course, we can send more emails or discussions. Yeah.
A good work, just a few comments. So that so when you have the swarm attestation, then the evidence will become very large. So we will have the fragmentation issues that you need to cut the message into several pieces. So maybe you can discuss.
I forgot to mention, but actually the message sizes we have for the three-way handshake with attestation materials are all less than 250 bytes. So they're quite reduced. And for swarm attestation, I still don't have the answer yet because I didn't start, and actually it's not relevant to my current draft. So yeah, maybe more discussions offline if you are curious about swarm attestation. Yeah.
Thank you very much. And any technical comments, please make sure they go to the Lake list as well, so that Lake is aware that any changes made were through feedback and discussion. And if you could keep us appraised of last call,
Yeah.
that would be very helpful. This was a nice overview. Thank you very
Thank
much.
you. Thank you. And also thank you for adjusting this time slot. Yeah. Thank you.
Thank you. Okay, next up we're 10 minutes ahead. Let's try to keep that time. It will probably go away at some point. We have Donghui Wang on distributed remote attestation, and you have 10 minutes. Thank you. And we're 10 minutes ahead.
Hello, everyone. I'm Donghui Wang, and thank you for the chair to give me the time slot to present our solution. And this solution is about distributed remote attestation. Next slide, please. Okay, and this solution is based on the RISE architecture, and in the RISE architecture, the remote attestation typically will involve the multiple kinds of roles, and there are two key points in the RISE architecture related to our document. The first one is the verifier is an actually trusted center, and another one is the attester needs to prove the freshness of the evidence. And the next slide, please. So our assumption is that with the increase of the network scale, when the network have multiple testers and multiple relying parties, the tester will receive a lot of attestation requests, and it will become overwhelmed with the multiple testing requests. So for some small and constrained testers, it could limit its functionalities. This is some concern from the tester point of view. And from another point of view is that with an increase of the testers and relying parties, there will be require more and more verifiers to implement the verifications work. So in order to prevent the verification from becoming a bottleneck. So we assume that in the future, there will be more and more organizations to act as a verifier to provide the verification service to the testers and relying parties. So when the network having multiple verifiers, it will provide the attester with more options. For example, for some site, for the relying site A, they will trust the verifier A, and for the relying party site B, they will trust the verifier B. So for the attester, if he want to communicate with relying party set A or relying party set B, it will need to generate multiple attestation evidence for different verifiers. So it is costly for the tester. So we are thinking if there is some method that could enable the tester just to generate one attestation evidence, and this evidence could be verified by different verifiers. So this is the assumption one, key issue one. And key issue two is that if we have multiple verifiers in the network, and we need to share some necessary information from the multiple entities in the network. For example, we can share the attestation result from verifier A to verifier B, or we can share some public keys from the public keys of the different verifiers to different site of the relying parties. So this is a two key issue in our document. And next slide, please. Next slide, please. Yes, and this slide shows the basic distributed remote attestation architecture that will involve the distributed ledger as a middleware among the multiple entities. And please notice that we didn't change any RISE architecture. We just add a new middleware distributed ledger in the architecture to enable the communication more efficiently and more conveniently. And every entity in the architecture can communicate to the distributed ledger to upload their critical information and to retrieve the data that others sharing. For example, the reference value provider can upload their reference value to the distributed ledger, and the hardware manufacturer as an endorser can upload their public key to the distributed ledger. And another point of view is that from the tester, he can get a public challenge from the distributed ledger. And I will give a detailed introduction about the public challenge. That we can say that if a test in the current technology, if the tester want to generate an attestation evidence, it can need to prove its freshness. So it used to contain some fresh data into its evidence. For example, the fresh data could be a challenge from the verifier or from the enrolling party. It also could be some epoch ID. It also could be some timestamp that contains in the evidence. So the public challenge is that the latest or the newest block hash on the blockchain. So we all know that the blockchain is deployed in a distributed manner. So the hash of the latest block is unpredictable for everyone. And as it is maintained by multi-parties, so I think the distributed ledger is enough for the verifiers. So we use the hash of the latest block in the blockchain in the procedure of attestation evidence generation. So the attestation evidence can be verified by multiple verifiers. Sorry, Thomas. So what has you have? Sorry?
What's your preference? Questions now or when you're done?
Yes, okay.
Right. So using the ledger as the epoch bell, basically, right? So is what you're proposing. But the thing that I'm not sure about is that an epoch bell normally, I would say, will define its own pace, right, at which the actual epoch IDs are minted and distributed. Whereas here, there seems to be no control, right? However, the ledger is used is the thing that will create the epoch ID, right? The pace of the epoch ID depends on the interaction model of the participant, isn't it? So that might be.
So the question is the public challenge could be an epoch ID? Yeah. Yes, I agree with you. We can consider that it is a kind of implementation of the epoch ID. It's a distributed epoch ID.
Yes, okay. And I understand this. The thing that I was trying to, the point I was trying to make is that the pace of minting epoch IDs is not under control of the ledger, right?
It's not controlled by the ledger because it is generated based on the consensus mechanism. So there is a centralized entity can generate the hash of the next block.
And this might be a bit problematic, but we can discuss this.
Okay, thank you. Okay. Okay, I continue my presentation. And sorry, previous slides. I didn't finish. Thank you. And from the verifiers perspective, it can upload its public key to the distributed ledger, and it also can get the reference value and the public key of the endorsers from the ledger to verify the attestation evidence it received from the tester. And after a successful attestation, it will send the testing result for the distributed ledger. And for the relying parties, they can get the testing result easily from the ledger. So summary, we can see that the distributed ledger can provide three key functions. The first one is the attestation result sharing, and verifiers can publish their attestation result and allowing other verifiers or relying parties to reuse this result. And next one is the public challenge provider, that testers can use the hash of the newest block in the DL as a public challenge. And the last one is some critical or necessary resource sharing, for example, the public keys and the reference values from the no matter reference value, endorsers, and verifiers. Okay, next slide, please. And we gave some, okay,
You want to take questions now?
okay.
So I believe that you are increasing the complexity a lot. I still don't understand. If you could please go back to the slide number 3, where you have the key issues. So you are saying you have multiple verifiers, right? So that would be an implementation issue. I think we are increasing the complexity a lot by using this kind of public nonce and all these things. So my question still to you is, and also to the multi-verifier draft would be, why not use this one verifier, and why exactly do you, why do you think this is an issue? Let's put it this way. So why is using one verifier an issue? The first point on your key issues.
She had said in the beginning, so for her arguments, but this will have to go to the list
Okay,
because I
sure.
think the discussion's going to be too long. Her initial premise was the load was too high on a more complex network. I think we're going to have a lot more discussion on this. I think a few of us have questions,
Okay,
and I had the same as yours. So
okay, we can have offline discussion after the meeting. Okay, so how many times?
we have Andrew
Okay.
is in the queue, and then we'll go to the next patient after that.
Yeah, I had one question, which I think was about the next slide, the one with the pink background. So I'm wondering what security services the distributed ledger needs to provide. I mean, isn't it? We need to have a we need to have a nonce, but I'm interested in whether using some part of a blockchain is better than just using a clock as a nonce, for example. And then on top of that, once you have a secure nonce that's not going to be repeated, can't everything just publish its results? I mean, the various pieces of evidence coming from the attester, for example, are already signed. And so if everything is signed, why does it need to go into a blockchain? Is what I'm failing to get. If it's a long answer, then happy to follow up on the list.
Thank you. As I said, the blockchain hash is just one implementation of the epoch ID and the nonce. So we can say the half epoch ID and half nonce. And as you see, the timestamp I think is not workable for every entities, but for those entities that doesn't support the synchronized clock inside, it can use the public key. It can use the public challenge, the hash of the blockchain. So I think it's just one benefit that we involve the distributed ledger into rights. And the main purpose is that another benefit is that we can share in a lot of information through via the distributed ledger.
Sharing the information I get, but I'm trying to work out why we need an extra layer of integrity protection, which I think is what you're suggesting the distributed ledger is providing.
Yes, I think it is an optional solution for the rights. And for the entities who doesn't support who doesn't have a lot of computing resources, and he want to communicate with a lot of relying party and verifiers, it can use this architecture. But I think it is a supplement of the rights. It's not going to change or modify the rights architecture.
Okay, thank you.
Okay, thank you. I think I can give more details about the architecture. Next slide, please. And we give 3 detailed pattern of the distributed remote attestation. The first one is all the publication, attestation, verification is based on the blockchain, that we can put partial verification logic as a smart contract. So this is a basic idea. Next slide, please. The The next one is on-chain based publication and off-chain based attestation and verification. That the on-chain based publication is that every entity can publish their critical data, for example, the reference value and the public key or the tested result to the distributed ledger. And off-chain based attestation is use the classical attestation that the verifier can send a challenge to the attester and receive the attestation evidence from the attester. And yes, this is the off-chain based attestation and verification. And the next slide, please. Above is some, we just introduced some optional DRA architecture, and we have a further discussion about the protectability of the public challenge. That is because the blockchain generation mechanism of the DL is driven by a consensus algorithm. So even a node holder of the blockchain cannot predict the next hash of the block, and it will generate predictably, so it can prove. It can also prove the freshness of the challenge. Okay, next slide, please.
Okay, and we're gonna have to ask you to, we're very booked today, so you're overtime already. So maybe
Okay.
1 or 2 more minutes to wrap up, please.
Okay, I have
Sorry.
already finished. Thank you.
Oh, very good.
yeah,
Thank you.
finished. Thank you.
Great, thank you. We'll take questions to the list. And Derek, can you please promote yourself so that you can be seen? And enable your camera and mic. Derek Welsky, he's presenting RAT's posture assessment. So it's my draft. He's joining in on the fun. So this is his first IETF. And hopefully he's figuring out how to use the buttons to enable his camera and mic. Maybe we have to go to the next presentation and then come back for the interest of time. He's using the full client? Okay. All right, so, oh, great. There he is. All right, thank you, Derek. It's all yours.
Amazing.
Minutes.
Can everyone hear me?
Yes, and Ned will advance your slides as you're ready.
Wonderful. Thank you, Ned. Good afternoon, everyone, and good morning to those that are dialed in or streaming in. So today we'll be reviewing the RATS posture assessment current draft. My name is Derek Welsky. Next slide, please. So this draft aims to define standardized claims that support scalable remote posture assessment using structured evidence. The purpose of this presentation is just to provide a current update on the draft. We'll also go through just outstanding comments and requests for comment. So as you know, this work is grounded in the principle that posture should be appraised not just through raw attestation data, but through policy-aware summaries, and that a verifier can use a scaled process across systems, containers, and applications. So we propose a method to summarize a platform security posture using a single remote attestation token. So this is composed of claims like MPS, LEM, and PCR. I also wanted to review just the technical pedigree of this document. So this builds on some prior work, such as AR4SI, so that's attestation results for secure interactions. That draft standardized how results are structured and interpreted downstream. It also builds on the EAT, measured component, which formalizes how device components like firmware, bootloaders, or container runtimes are described cryptographically in verifiable ways. And then lastly, it also builds on EAR, which defines how attestation evidence is carried with EAT tokens. And that EAR enables interoperability across the testers and verifiers. I think I see a hand in the audience, if I'm not mistaken.
Hi, Derek. Welcome, first of all. Second, is there a typo there in ER specifying structure evidence? Because it's an attestation result format. So.
Yes, that is a typo.
Okay, cool.
Yes, thank you. Yeah, we'll make sure to capture that. Thank you. And was that Thomas?
Yes, that was Thomas.
Thank you, Thomas. So just going back to the spirit and the purpose of this update. So we argue in this this draft that this is essential because modern deployments are increasingly heterogeneous, distributed, and policy driven. And we're introducing claims such as the MPS, the measured or policy set, LEM, the linked evidence metadata, and then PCR. So this just brings me to the current state of this draft. So this draft allows verifiers to appraise posture from any attester using a uniform token without requiring logic for TPMs, DICE CDIs, or custom enclave formats. As far as just where we stand on this current draft, so the most recent draft introduces two major additions. This is in addition to Appendix A. And so firstly, we've added an extended claims table. This maps core RPA SCA claims, so MPS, LEM, PCR, to status indicators across log formats and implementation cases. It also clarifies which claims are required, optional, or derived. Additionally, we have a separate table so that was Appendix A1. Appendix A2 adds a hardware root of trust comparison table. This compares four other root of trust ROT schema for DICE, Apple Secure Enclave, OpenTitan, and then Nitro TPM. And then I'll go to the next slide, please, Ned. So as I mentioned before, just the current draft status. So this is draft 3. We've included, as I noted just before, 3 major updates to Appendix A1, updates to Appendix A2. Those are the detailed mappings of RPA SCA. We've added an extended claims table. This provides clarity on when and how each claim is generated. And then, of course, cross-linking with EAT and EAR. Where we are in work in progress, so there's a few areas that are still under refinement. Firstly, some outstanding comments were to add some visual aids, anything by way of architecture diagrams, so we can illustrate, token generation and consumption. There's also additional outstanding comments for policy definition and clarification. There's comments around claim encoding, the need to resolve serialization and encoding specific LEM formats, posture federation semantics, and then namespace and considerations, specifically how to define MPS identifiers around URI format, policy registers, and vendor prefixes. And just closing this out, and thank you everyone for the time today. So we do believe that this is a meaningful step towards policy-aware, scalable, and cross-platform posture assessment. This builds on IETF's foundational work in RATS, and we're seeking further feedback and community support around real-world use cases, claims usability, and then also just suggestions for standardizing or federating MPS references. So with that, I will yield back my time. Thank you.
Any questions?
Peter.
Oh, yes, there's a
Yes.
queue. So Peter is up.
Hi, this is Peter from Huawei. So I have a question about what are the specific measurements that's gonna be conducted from where I see these are measurement sets. So are they only measurements like about root of trust and their behaviors, or some more upper level behaviors? So that's my question.
Yeah. And thank you, Peter. So we would look at 3 measurement sets. So this would be the MPS measurement policy set, LEM, and then PCR.
So basically, the MPS is will map back to a known policy set. It could be like a DISA-STIG, or it could be a portion of a DISA-STIG. So there could be a number of policy or configuration or measurements that comprise that policy set. It is higher level than the trustworthiness and other aspects that are already being addressed. Does that make sense?
Yes, makes sense. And yeah, I think that's good. I think just to leave more extensibility on that one would be better. You know, for
yes, there's an IANA table. We're establishing an IANA table so that you can register those, or we'll have some type of registry format. We can figure that out.
Sometimes there, you know, when we do posture assessment, we do a lot of things, and many security companies, they have different ways to measure. Like, for example, let me make an example, is that how fast that a phone that switch their MAC address, or that kind of, all variety of things. So I think if it's good for extension in the future, that's going to be very nice. Just comment.
Thank you.
Thank you.
Yeah,
Osama?
welcome Derek to the first IETF. Welcome, and I would like to say, I would like to understand better what would be the overlap with the attestation protocol specifically, and I would like to contribute towards that. Happy to see this work proceeding.
Thank you. Hank?
Yeah, hi, this is Henk. So I think all this builds on the definition of evidence in the RFC 9334, where the trustworthiness is established, and then there's this tiny word, telemetry. And I think we're building something here that is in the TCB of the attester and gives you more than the base evidence. It's about trustworthiness. It's all the compliance checks on the same telemetry channel that we established to establish trustworthiness before. And I think that's great. Secondly, I like the rules of trust mapping section. It is not specific to this document, actually. It is a generic appendix, so we might want to find a place. It's a good place for now, but it might become its own document maybe, or somewhere else. So this is also interesting. And yeah, I think as we extend telemetry on the one side, we might want to be a little more simple with evidence on the other side. It's off topic. I'm highlighting the slides that Michael just proposed again, and maybe we'll talk about that a little bit.
Okay, great. We can talk about that offline and what the right place is. Derek actually has a lot of really nice text that he generated that would go above and beyond what would go in this draft on the various roots of trust with some analysis there. So there could be some other place for it. I didn't know if it was a draft though, but let's talk. Yeah. Thank you, Derek. I hope you don't mind me sharing that on your behalf.
I definitely don't mind. I was going to address the prior question, unless there were more questions we wanted to.
I think that's it. So thank you very
Amazing.
much. We'll go to the next presentation on the agenda, and that is extending trusted path routing issues and runtime trust assessment and monitoring INS Crontiers.
Okay, thank you. We can have the questions at the end, I think. I only have a couple of slides anyway, but I would just submitted a small draft. So on the next slide, I explain a little bit the motivation about it. But basically, the idea is that secure routing in 5G, 6G needs to go beyond traditional methods by considering the trustworthiness of devices and paths in runtime, meaning applying a continuous trust evaluation and validation of mechanisms for paths. And the idea is that, I mean, we already have a draft on the trusted path routing that has established a good solution for trusted path routing based on onboarding time attestation, and that validates initial state of devices So what we have proposed in the draft is to have an incremental study on top of it about how to extend this to runtime behavior and evaluating trust based on threat exposure of devices in runtime. So in the draft, we just go through some challenges. So the first step would be just to list some challenges, discuss and take feedback, and take it from there. So in the next slide, I just list the most important challenges that we see on extending this thing on the dynamic runtime situation. So, of course, the first thing is that devices supplied by different vendors may implement different attestation models, which means the evidence coming from the devices might vary on assurance levels, formats, and semantic interpretations. In the existing draft, we have only one kind of evidence. Here, if we are going to extend on more sources of evidence, we have to consider this kind of supporting kind of composite attestation, so where its evidence must be cryptographically bound to the secure attestation function to be able to verify it in a uniform way. The second aspect is the efficiency. I mean, if it has to be done in runtime, it has to be efficient and fast. And then there was a question, like a discussion, which kind of mechanism we have to employ, like retrieving evidence with asynchronous or asynchronous mechanisms. But the most efficient way probably means using implicit attestation and asynchronous evidence signaling, meaning that the attesters detect internal changes of the trust state and notify verifiers. So again, this opens up a new challenge how to do that. And then the third question, the third challenge has to do more how do we elevate this assessment to the path level, right? Not just looking at the devices. So aggregating, rather than aggregating raw evidence, I mean, there is some discussion or one approach in Nasser, I think, where it says, okay, we collect evidence from routers or devices in general. But rather than that, it can also be maybe a better approach to have runtime attestation composed by trustworthiness claims coming from the part of verification process inside the devices themselves, again, pointing back to implicit attestation and communicating these trustworthiness claims in a coherent, ordered, and temporally aligned path level view. And the fourth and last challenge that we discuss is the interoperability of semantics. If we are going to extend this not only to inter-domain situation where you have different domains and you have to consider interoperability aspects and semantics for expressing and appraising trust claims between domains. And this includes different questions like privacy preserving evidence exchange, coordination across independent verifiers, alignment of trust models, so that everything can work across domains. So Yeah, so this is only a very short draft. Just to open the discussion, we would really welcome feedback and discussions, and we see how we move on from there. And I think in the next slide, I only have just pointers to other drafts that discuss or can be of
நிறைய
use.
டைம் ஆகும் போது நிறைய டைம் ஆகும்
That's
போது
it.
எது 15 நிமிஷம் தெரியல இருமா
Some of us
15 நிமிஷம் கழிஞ்சா வர
We're
முடியாது.
getting some crosstalk. Everybody check your mic.
Yeah, I think someone has that. Okay, good. Thanks a lot. There is one in the queue, I think.
Usama is in the queue.
Yeah, so just trying to understand the motivation or maybe the use case that you have for runtime attestation, and is it in the use case that you have at the runtime things are changing, like the attestation claims are changing, and you want to have some guarantee that the changes are captured? Is this the kind of use case that you have that you are calling as posture assessment? And so is it basically that you have established a connection and things are changing at the runtime? Is it what you call as runtime monitoring? And or do you have some other interpretation of this?
Okay, so I mean, to answer in general, the motivation thinking of use case, like thinking what exactly is the motivation for this, and what I have in my mind is more, the trend of integrating cognitive computing in networks now. And we saw a lot of these discussions this week, I think. If you followed any of the discussions about AI agents this week, or, in general, bringing more of the decision logic inside the networks in a very dynamic way. So you have services that that incorporate this establishment of dynamic paths to how can I say, aligning with computation logic and decision logic.
I mean, just to clarify my question, so your use case is still Nasser, or is it some other use case in addition to Nasser?
No, I think I take the point of view of assessment of the trust state of the devices, like the trusted path routing draft is doing.
Okay.
So which right now only takes more consideration on the onboarding of the devices, but what happens after that, we still need to see, like when the state changes after.
Okay, thank you.
Yeah.
We have Peter, and we are over time, so let's just keep it moving and ask quickly. Thank you.
Yeah, I'll be real quick. Not as an author about for this draft. I just want to explain the motivation for NASA is to avoid potentially vulnerable devices that may lead to data loss or that kind of threat. So I'll say this thing, I'm just trying to explain that that's the original motivation.
Yeah.
But this draft is, I'll say, mostly come from the questions that was raised from last BOF, because people was raising those kind of questions. I'll say this is not just a NASA problem. This could be somehow a more generic problem that how do we really standardize how we do runtime trustworthiness assessment in any kind of use case. Just maybe it doesn't have to be restricted to NASA, and that's just a comment.
Thank you. That's a nice clarification. I agree. Okay, thanks a lot.
Thank you. Next up, we have Michael and Hank on evidence versus trusted self-assertions. 5 minutes.
So I'm obviously the bad cop because I am here before Michael can arrive, and therefore, and so next slide, please. It's just on the slide. So we picked figure 2 from the RETS architecture, which basically shows the very minimum composition of an attester. And we want to point out where does evidence come from. And this picture basically tells you it's the attesting environment. Fine. So now the title of this talk is Evidence versus Trusted Self-Assertions. And Micah might have also an opinion about that.
So the issue is that the testing environment in this box is different than the target environment, and therefore can have an independent opinion despite what the target environment is doing. More and more, we have situations where we want a device to provide evidence about itself, and we do not have a separate set of environments. So the device might be even more considered more secure, you know, fuse blown, CPU, everything in single system on chip, device filled with epoxy, you know, there's no way to get in and out of it, right? Many things are like that. So the question is, can we still refer to these as, you know, evidence, and given that this situation, right? And the claim, what we're essentially saying is, well, those fit into our architecture as well, but we have to kind of squint a little bit. And so what we're essentially saying is, well, in those environments, these are really self-asserted claims, because the device is saying something about itself. And at one level, the only thing that you can actually really trust from outside is that there are certain endorsements. So if you can get the device to make some statement using its private key, then you can trust that that device has access to the private key and it's making an assertion, and there may be some endorsements that tell you something else about the device that work. Okay, and that's really
so I'm a bad cop. So in a nutshell, a root of trust can't create evidence about itself. That's the issue. So so the testing environment can't talk about itself, but as Michael thinks, and I'm playing a little bit here because I think he's right. So as Michael thinks, as this is actually a common thing. So even established roots of trust that are in confidential computing, creating, I want to say, directly evidence from the hardware base, function a little bit similar. The most important thing is that the private key in that system is
unattainable outside, is, I don't know, secure. What do you want me to say?
Endorsed.
Endorsed. Yeah, endorsed.
So we are going with the terminology here again. And as we said earlier, evidence includes a tricky word telemetry that goes beyond trustworthiness in its traditional sense. So now we are figuring out how to put this, and I think we came up, the current compromise of the week is endorsed assertion.
Yes.
And there might be better things than that, because you can see already faces in the group. Exactly. But I want to bring the topic up, and this might be the first step towards some other discussions in the terminology realm. We just want to warn you, because we might bicker about this and need more bashing and more input and all that.
Okay, so we have 4 people in the queue, and we are at time for the 5 minutes allotted for this. This will definitely require more, this is terminology bashing. I'm going to say, let's not do this now.
No.
We don't have a good term. We just have something off the cuff that maybe happened over some tea and cheese, knowing Hank, and
Without the tea or the cheese.
Now, that was really nice. Thank you.
You're welcome. All right, next presentation, please. We have remote attestation with multiple verifiers. There were several side meetings on this topic. There was some good discussion on list. So hopefully this, I think we can keep this to time, because I think most of us are familiar now.
Yeah.
Thank you.
I want to keep time. So we will report the progress of the remote attestation with multiple verifiers. The first thing that, okay, now we have a new title, which is different from the last version. And the other thing that, so I present the remote attestation with multiple verifiers last year in Dublin, but this is a totally new draft with no new themes. So do not mix this draft with the old draft. So next slide. So we have here's a recap of the hackathon. So basically, we're doing the brainstorm to face the critical problem why that one verifier is sufficient, why you need to consider the multiple verifiers. So for after discussion for actually 1 day and a half, so we reach as a certain consensus from the team, so that actually, so when the attester itself is composite, meaning that in a device you have the CPU and GPU. So you already have some verifiers that dedicate for each sub-component. For example, Intel has its verifiers for the CPU, and NVIDIA has its verifier for the GPU. And also other cases that, so for some attester or components, they have the trust for only part of the verifiers, and there's some verifiers only have certain capabilities to dealing with certain evidence. And also, in certain cases, there's restrictions for the GDPR or some regulations that you need to put some verifier in certain countries or in certain domains. In that case, that the attester will trust such kind of verifier. And also that we will have different appraisal policies for different attesters, so they want to have different verifiers. Okay, so next page. And during this IETF, we have 2 side meetings in Wednesday and Thursday, so very excited talks. So actually, we are not just covering the multiple VerSubs, we are talking about a big picture of when the device become composite. So how we to deal with the evidence, endorsements, and the verifications, and attestation results. So during these 2 side meetings, there's a certain consensus. We think that, okay, there's really a need for the multiple verifiers when the device is composite. So examples is the CPU, GPU, and other things. And will someone let me finish this page? And so when there exists multiple verifiers, we need to have some guidance to how to let these verifiers talk to each other in the standardized ways, and how to formalize the topologies to between the attesters to these verifiers, and how to formalize the message formats, and to avoid fragmentation. Next slide. So as for the draft, so this is what we changed from the interim meetings that we received many useful comments. So we updated the titles according to the suggestions, and we add section 2 to explain the motivation of this draft. And we add a lot of page part in the security and the privacy considerations, and we update the teams, and there's some minor corrections. So next page. So we think that it is within the scope of the working group, and in the future, we will define the topology patterns and the standard interface message exchange between multiple verifiers. So here we want to have your opinions on the adoption of this draft. Thank you. So now it's the time for the Q&A.
Great. Usama is first.
Yeah, thank you very much. I have a lot of comments, but I will keep it short. First of all, you mentioned GDPR, and I would really like to see exact clause of GDPR which says that you need multiple verifiers, because I'm really not convinced that it is, or it should be a part of GDPR to say that you need multiple verifiers. It totally makes no sense to me for GDPR, a legal regulation, to say you could have multiple verifiers. Secondly, you mentioned CPU and GPU as the use case. I am not convinced that is a motivation for multiple verifiers. The reason being already clarified in issue 19 that you presented last time. The third thing that you mentioned was 2 side meetings, and you claimed that there was a consensus. I would like to say that side meetings are not part of the official IETF proceedings, and that doesn't have any value whatsoever. Whatever you have a consensus, that's just up to you and the people who were there. I would like to see some motivation or someone speaking up why that consensus was developed. First of all, that's not consensus at all. So that's just a side meeting. That's not part of the IETF proceedings. I would like people to justify what that motivation was. I would like to see it in as part of the original RATS meeting.
Yes,
Chairs may
there's
correct
also,
me if I'm wrong.
there's also contributions to the list. So that does, it's okay that there was a side meeting to develop this further to get people familiar. And then it did come to the list and he's presenting now. So I think we just have to figure out, is there more work to come to agreement to adopt, or is this ready for adoption, right? That's what we're looking for in this discussion.
So my concerns were not addressed yet. I am still failing to see what the motivation is. The issue number 19 has not yet been addressed. I don't see, or at least myself, I don't support adoption at all. Or rather to put it differently, I'm strongly in opposition of adoption.
Thank you.
Okay, thank you, Usama. Just clarification
Yogesh?
Yeah. It's,
Yogesh?
Yeah, I just wanted to very clearly say that there was a, when we presented this in interim, there was a great motivation felt. And this, everybody like, I don't want to name, but people from different organizations said you need to clearly state the motivation. We really worked hard on the motivation, added motivation to the draft. Usama had a concern on issue 19. If everybody is free to go on the GitHub, look at the issue 19 and a clear explanation of why the work is so important for the ecosystem is very clearly highlighted there. So I would request everyone. And we echoed the same motivation in the side meetings, and we requested an explicit feedback from the audience in the RATS working group. And thank you to all those who have, potentially everyone has stated their strong commitment to the work in this direction. That's what I would like to add, and we'll leave to Thomas to do the further work. Thank you for clarification.
Okay, Thomas Fossati. Usama, regarding the GPU, CPU use case, that's a very strong one. I think in the sense that once you have split the verification function across, say, a front-end verifier and back-end verifier, then you want that path to be standardized because that's an interface that's important to keep regular, okay, not vendor-specific. And so this is a clarification, an answer for Usama. And another question that I have here about the draft is scope. And I'd like to understand whether this draft is concerned with the architectural aspects only, or do you want to go to the specification of the interfaces within this document? That's what I want to understand. What we are asked to adopt here.
Yeah.
Is just the architectural stuff, or is the architectural plus?
So it's not just the architecture, because you see that we need to have a language talking to the verifiers, and I have the language how to let the attester know that which kind of verifier to choose. Actually, you see that the work in the LALAKE and the CSI, they are already talking about how to select the verifiers using the hint, and in the insurance case, they have some verify ID. I think all this work can be integrated into this multi-verify framework to have the standard ways to dealing with this challenge, not just limited to certain specific protocols.
Okay.
And also the magic format is very important because some cases, some entities have two roles, that it is attester and in the same time it is verified. So we need to transform the evidence to the attesting result, and it becomes evidence for the next verifiers. So this is also the challenges we are dealing with in this draft.
I understand that these are the real concrete things to solve. Just wanting to understand whether this work goes in the draft or somewhere else.
Thank you.
Okay, since we're really tight on time, we did put a poll while we're working on the queue just to see who's interested in contributing, not a call for adoption yet. We're just trying to get that first feel while we have the discussion. And we'll leave that poll open as the discussion happens. So
Thank you.
can
Yeah,
change
that was
your
I ran back
response.
just to raise that. Yeah, so just emphasizing, we actually solicited this input. Everybody who was at the site meetings, it's on the list. It's documented on the REDS list. There's a strong feedback, I want to say, and that's all I'm saying. So these are not here in the room anymore. They're all flying out. So maybe add these numbers to the number here, and then you approximately get a good result.
Yeah, thank you. So we have received some feedback from the mailing list after the site meeting. So we have Yuxuan and Manu are supporting us, and there are other two. Yeah.
So just to clarify my concern, building on top of what Thomas was saying. So what I'm saying basically is that with a single verifier, you can get all the reference values and you can compare with that. You want to go first? Okay. So, getting all these reference values is possible for one verifier. And by having multi-verifiers, you are basically increasing the complexity.
This is not because we will create multiple verifiers. It's like that, okay, in IETF, we will have one hotel, but I do not live in the hotel, I'm IETF. So we do not create a hotel, everyone can be inside, because this is the status, right? So currently, there's already some use cases. They are separate verifiers for the CPU and verified for GPU. And if in future, we can see that then when they are different kind of verifiers, they are not built by the single vendors. So how to talk to them?
Right.
So it is not that, okay, so it's okay, we can have a verified to build up, but there's no need if they are already there. We do not need to merge them to one to say, okay, all of these hotels are IETF hotel. So no need to do that, right?
Okay. So
Okay, we are over time, which means the whole entire RAT session is going to run over. The queue is locked after our esteemed area director.
So I'm Deb Cooley. I am your responsible area director, and I am warning you that you are not permitted to do working group work inside meetings. So the fact that you held a side meeting for this work that you're then going to ask for adoption for is not the way we do business. You can run interims up to 2 weeks before or after meetings. You can do things like that, but you may not use side meetings to do working group work.
It's not adopted, though.
It doesn't matter. So they did the side meeting and they came here and they asked for adoption. That's working group work. They can do it in an interim. It doesn't matter. You still do work on non-adopted drafts in the working group. You can run an interim. You can run an interim. You can have an interim. That's your options. Your options are interims, not side meetings. Side meetings are not actually part of the IETF. Did you know that?
If you look at all the side meetings, they are already working group stuff.
No, there's no, they're not, or they're not supposed to
So
be.
no design team meetings of work that has not been adopted.
They didn't call this a design meeting.
Well, I did. He did. He called it something.
That's right. That's right.
I
Who's
looked
briefing?
at it as a design team meeting.
So you
Right,
need to
so
be
it
very,
wasn't
you need to be very
adopted.
careful. There's very limited side meeting space. There's very little session meeting space. You should do more work in interims, or you should do design meetings on the side, not at meetings, right? But technically, if somebody looks at this and says, this is rat's work in a side meeting, we will all get in trouble.
Okay, thank you.
So I can point you to working groups where this has happened.
And I will point you the list of things which has happened.
Okay, so there's mixed interest from the poll. There are just 8 people interested. I think we'll take this to the list and perhaps an interim for more discussion before we get to a point of an adoption call.
Okay.
Thank you
Okay,
very
thank you.
much. All right, next up, thank you very much for being ready. And this is PKIC's evidence for remote attestation of hardware security modules.
My name is Jean-Pierre Fizet. I'm here representing my co-authors. Next slide, I'll try to go fast. This draft was, well, this work was known as key attestation. The title has changed a couple of times. The current title is PKIX evidence for hardware security module. I don't like the title. It might change again. There's been 3 or 4 versions of this flying around. Since March, since Bangkok, we've been trying to work on lining up the language and definition with RFC 9334. This is because we're between 2 domains, the PKIX and RATs, and some words collide. And so we're trying to deal with that. Since then, we've separated, as requested by the group, the information model from the data model. We've stabilized the ASN1. We've introduced a new role called the presenter. And this is because in all the 9334 diagrams that you see, there's an arrow that starts from the attester that goes towards the verifier. But the reality, in general, you will have an entity that requests for this evidence to be generated. In the case of an HSM, it's like a crypto module. It will not just start sending evidence on its own. And so the presenter basically asks for the generation of the evidence, then takes the evidence that is captured and sent to the verifier. So that's the new role. We've added a section on attestation request. This is basically the presenter asking the attester to generate the evidence. Next slide, please. So currently, the current work is we're continuing our bi-weekly meetings. These meetings are attended with the CSR test group as well. So, sure. We're addressing GitHub issues as they're coming up. I would like to thank Kathleen for a good review, and I'd like to do a special mention to Jeff Henderson from Google, who really went through and provided really good suggestions. We'd like to have a complete functional implementation of this past Montreal. We're all trying to reach working group last call, so this is always the dream for anybody working here. And so the next slide, please. I'm standing in front of you today because I'm asking you a question about some nomenclature. So I'll explain to you quickly what the information model is. So basically, it looks like any other envelope. You've got a to be signed section, and inside of this, you've got a number of entities. The entities currently, as defined in the specification, come in three classes. You have platform entity, you have a key entity, and a transaction entity. These are defined by OIDs because we're doing everything in the ASN1. These entities have a collection of attributes. These attributes are associated with a type and a value. The type is based on OID again, so it's completely extensible. So the nature of the value associated with the attribute is defined by the type. So it could be an integer, it could be a byte, some bytes, strings, and stuff like that. So what's happening is, in general, in RATs, when you produce evidence, the evidence carries claims and measurements. And what I've done here, what we've done as a group, we've put in drop-in names, entities, and attributes to not step on anyone's toes, right? But I feel that prior to continuing this work, we need to define what that is, because there's often like a collision when we discuss these things. Well, this is a claim. Well, this is a measurement. And you guys all know, you all write specifications. It's quite expensive when somebody comes in and says, oh, we're going to change this term, and then you basically have to rewrite everything, right? And so I wouldn't say that we're stalled, but I'm kind of waiting for an agreement on what the nomenclature is going to be before we sink in more work into this. So can we go to the next slide? These are the questions, basically. So evidence is made out of claims. Should the concept of attribute be renamed to claim and stuff like that? There's language collisions. Attestation request, I think, is the right term. You basically have a presenter that is asking an attester for something to do. So I think attestation request is a good enough name. And obviously, Hank and Mike just showed like this concept of evidence versus trusted self-assertion. So I'm going to have to see after the dust settles in the next couple of weeks as to how it affects us as well. And so this is mostly me asking you guys a question about the nomenclature. I'd like to take that to the list because I have a feeling we don't have much time for a conversation, do we? So
We're 3 minutes over, so I
right.
appreciate that. Yeah, I think your draft is in a good place to keep it on the list. I reviewed it as well and had some feedback. Yes.
Thank you very much.
Thank you, and I appreciate the time back. And so does the next speaker, who is proof of Ramkey, proof of residency aware location claim for confidential computing.
Yes, can you hear me? I'm remote.
Yes, thank you.
Okay, awesome. If I could walk through the slides myself, that'll be great.
Ned is bringing those up.
Yeah.
It's Ramkey. He's there waiting, ready to speak, looking for his slides.
So while he's looking for the slides, sorry, Kathleen, what was the action for the last draft? So you will provide feedback?
We're going to talk on the, I already did, didn't I send my feedback to the list?
Okay, sorry, I really missed it. So what was the action that you
We're
said?
going to discuss on list. There's
Oh,
more work
discuss on
to be
list.
done.
Okay.
He discussed some of the items that are
Okay,
in the
thank you.
works right now, and discussion is needed though. So if you have reviews, please put those forward. I think it's, a mix of terminology, and there was a good shift from version 00 to 01 is what I noticed. And then
is
there's
this the
just
right
more
presentation?
alignment needed. Go ahead, Ned, sorry.
This
Oh,
is
now
the
we're seeing it.
presentation I found. Is this the right one? It doesn't match the title you were giving.
Ah, right. So Ramkey, this one says Zero Trust Sovereign AI Rats Impact. Is that right?
That's correct. Yeah.
Yes, thank you.
Thank you. Thank you, Kathleen. So let's walk through the agenda. First, we'll go through sovereign cloud data residency requirements, then key industry problems and solutions summary with sovereign cloud AI inferencing as an example. Then we'll look at a summary of key protocol changes and suggested next steps. Next slide, please. Or if I can drive, that'll be great.
It should be up.
Oh, perfect. Yeah. Yeah. So let's look at the data residency requirements. First is let's start with the technical and regulatory challenges. Basically, the data protection regulations, EUDR, US HIPAA, PCI DSS, and local legal mandates, countries like Saudi Arabia. And we have to consider data protection in all its lifecycle management, from creation to destruction, and in all status, in transit, in use, and at rest. What this results in the set of technical requirements for data residency. First is the host affinity requirement. Data and storage processing must be tied to specific hosts. Geolocation affinity, data must be stored, processed only in a defined geographic region. And host geolocation affinity. If we combine both, essentially, the host is bound to geographic regions. Host affinity, geolocation affinity, and you combine both to host geolocation affinity or geofencing. Next slide, please. Let's look at an example use case and problem statement. Essentially, this is depicting a sovereign cloud AI inferencing example. The AI inferencing workload is, for example, in a sovereign cloud in Spain, hosted in sovereign cloud in Spain, in a CC workload host, right? And essentially, it is basically the very first step is essentially getting the secrets from the key vault, which is again running on a confidential computing host, right, in a HSM, right, to decrypt the AI model. It gets the key from the key vault, right, and then gets the encrypted model, right, second step, and then after that it decrypts the model, and then it's ready for inference. That is basically the third step. But fundamentally, as you can see, there are a couple of key challenges in this whole orchestrated workflow. First is, how do you realize the host affinity? The two challenges are, first is the proof of possession token, of course, bind the private key to the token. However, any workload orchestrator security misconfiguration, in fact, it's called out an OWASP, right, can still undermine them by a private key being used by any unauthorized workload. Essentially, you don't check for the workload identity of the code hash, while issuing the proof of possession token. The second is basically coming to the RATS key attestation draft. So the key missing pieces. One is the movement of key from key vault to the CC workload host, and HSM binding to the CC environment. This is basically coming to host affinity. The second is geolocation affinity realization challenges. So today the classic model is IP-based geofencing. Essentially, you have firewall rules check source IP. It basically offers only very weak location guarantees. Attackers can easily bypass it using VPNs, proxies, or IP spoofing. Next slide, please. Essentially, if you look at now the solution, right, basically the first element is essentially what we see is the key attestation is a solution to host affinity. The key gaps are described. The first step is essentially making sure we need proof that HSM or in other words, the private key which is managed by the HSM is bound to a specific CC host through attestation. That is the step number one in terms of getting secrets from the key vault by the CC workload. The second is basically the key vault interaction itself exists, that proof. First is getting the key from HSM, such as the key vault interaction exists for the CC workload. Right. This will make sure essentially solve the host affinity problem. But now the next aspect is essentially the geolocation affinity, and how do you address the graph? You enhance the EAT entity attestation token claim as follows. You prove that the geolocation sensor is trustworthy, right? The first step. And the second is proof that geolocation sensor is bound to a specific CC host through attestation. Right? These are the key steps. And essentially what this architecture is describing, this is really a summary. This is not trying to describe every piece. Basically, there is a workload identity agent. For example, SPP Spire server. Essentially what it does is attest workload during restart with host TPM attestation key, AK, using workload identity agent. One thing which is missing, which is not pointed out, but during boot time, you will do a measured boot to ensure that the system brings up only the trustworthy geolocation sensors. Right? That is a pre-step before, so it's simplified and not depicted here. And for example, it could integrate with an open source project such as Keylime. Once you know that, hey, it is not just the host and the host OS, but also the geolocation sensor is trustworthy, then you can safely during runtime, get a geolocation from those sensors. And there are several sensors in the market which can actually provide attested geolocation from hardware itself, right? Like basically, for example, even if the host OS is compromised, there's no problem. You get a signed geolocation right from the hardware. That's sort of the way of realizing this architecture. Next slide, please. So basically, from suggested next steps, essentially idea is to address key attestation solution gaps. Just to summarize, proof that HSM is bound to a specific CC host through attestation, proof that the key vault interaction exists for the CC workload, and again, the address the EAT gap in expressing a non-GPS location and geofence. So basically, GPS seems covered. And two gaps are currently only precise geolocation is defined. The second part is missing telco DC network triangulation. Mobile sensor is part of the server host. So just to kind of recap for you, the draft has got all the details, but basically when it comes to precise geolocation, there are several options, right? We often talk about GPS, but really we should think about it as GNSS, right? You have standard GPS, which is slightly spoofable, but then we have also Galileo GNSS, which is much less spoofable, right? And last but not least, completely different way of approaching the problem is basically a mobile network sensor. Just like leveraging this for mobile phones, you can, basically have that sensor in the server host, right? And then have an external antenna and triangulate to mobile towers. In fact, one good security property of this is basically it triangulates to several mobile towers, and it's suppose it triangulates to maybe 4 or 5 mobile towers. It's really hard to make any physical movement of more than even one of them, right? It's basically a superior threat model, addresses a superior threat model, even as compared to your GNSS type of location sensors. Just something to keep in mind, captured in the draft. And I think Michael had some very good discussion on the list. I do, at least in our standpoint, this is completely complementary. This evidence-based geolocation measurement is completely complementary to kind of the endorsement base, where an operator, essentially walks in and then picks up, where these devices are, essentially in a data center. That's it.
Okay, thank you. We have 2 people in the queue and 1 minute. Peter.
Yeah, I just have a clarifying question. So, are you trying to verify the geolocation of a accessing device or the geolocation of a data center?
In this case, the example I've depicted is
Can I go
geolocation
back
of
to the previous slide? That's easier to illustrate. Right.
Yeah. So basically, it's trying to validate the geolocation of a workload host of the running in sovereign cloud, right? Before picking up the key from a key vault, on-prem key vault. Okay.
Okay, if that's the case, because the firewall usually when they do zero trust or many factor verification, it kind of verifies the information from outside, right? So this picture is kind of confusing because it feels like the firewall is verifying the location of the end user host instead of the workload or the data center.
No, so basically, I was talking about this workflow. What is happening? There is a CC workload host running in the sovereign cloud, but then you have an on-prem key vault, right? I was talking about this path from the CC workload host to the key vault, right? That is my zoomed-in focus. You're right that this is also a use case, but I didn't talk about that for this, purpose.
Yeah, well, okay,
so that's yeah.
Yeah, so data sovereignty and host location and all that is very important. Geolocation, affinity, host affinity, that's really important. But if I remember correctly, I didn't see any strong evidence in the draft which comes from any paper other than yours. I saw that the co-authors here already have another paper that is referred, but I would like to see some other motivation other than the authors, like from some proper regulations that you are mentioning, like GDPR and so on. That would be interesting to see. I have a very quick other comment, that is adding the GPS to the confidential computing workloads might also lead to security problems. So that is something also that we would need to consider and is an important issue. But happy to contribute to this work.
No, thank you.
Okay, thank you. We are 2 minutes over, which means we're cutting into the last presentation for the day at this stage. So the next talk up is proof of position for auditor managed endorsements. Michael Richardson and Peter Liu.
Liu? Oh, yeah. Okay. Is it coming? Does this work? Can make it work?
I'm not finding the slides.
Because they have a big enough hammer?
It's on Ned's computer. Oh, really?
It's on the server.
Oh.
Okay.
A new deck is being shared.
I just don't see.
I can sing. Do, 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 do,
yeah, I don't see it.
Well, that's probably copyright. Probably getting us a copyright hit on YouTube now. Slides clicker. Now the clicker has control, but the clicker doesn't know how to load slides. Buffering.
Yeah, did somebody do something?
Sorry. You said you were taking me off the agenda, then you put me back on the agenda. You complain that everything's slow. Well, it just there's no, I can't, I'm clicking.
Yeah, I'm trying to, I just lost my connection, so.
So the clicker is great, but you have to remember you have to take the control back from the clicker, load the slides, give the control back to the clicker, and then, yeah. So then he has to load it, then he gives me the clicker control. There we go. There you go. Thank you very much. Okay, so, it's a play on words because usually it's proof of possession of a private key. So I'm playing on that. So thanks for understanding. This is about endorsements, not about things. What is typically endorsement, I'm going to run through this. Usually it's something else you say going on, but I understood endorsement better when I understood that my car is red is not something the car knows about, but that someone else can say something about it, right? So that's the real thing to understand about endorsement. So what's the rooted problem? Well, okay, this device is located at 151 Front Street, Toronto. That's, for example, that's where all of Canada's internet goes through. That is also where you should drop your if you want to do things to Canada, that's where you should go. But you can say, well, like, how do I know that router is there, right? Like, what if it's just someone's pretending that they have something there? So the answer, and this was, one of the pushbacks at the Nazarbayev was, like, well, you're going to do GPS. They're like, well, no, actually, we're not going to do GPS. I can barely get a mobile phone when I'm into a data center like that. I don't think we're going to get any GPS, and it's spoofable. So really what you want to do, you want to have somebody go physically up and find the device and say, I found the device. Not only did I find the device, but I found that there was a piece of fiber with a blue wrapper on it plugged into port 9. And I walked around the data center and I found that piece of fiber, led to Buffalo, which is exactly what I expected. So that's great. So what are we going to do about that? Okay, so walk up to some device, plug into it somehow, exchange some signed data. I'm calling this the device under, oh, I did my slide wrong. It's supposed to be device under audit, excuse me, there. So you can imagine you have a tablet with an on-the-go cable, and the latest thing is that routers don't have craft consoles anymore. They have USB-C ports, so that's really lovely because it simplifies so much. And you plug it in and you exchange some data. And I'm saying you go to the console port, so you can see, maybe you can see there's the console port, little USB. In that case, it's a micro, but anyway, there. So you do something. So this document is about doing something, okay? This is coming out, if you remember, in the days of dialing modems and UECP and things like this, and that's what I imagine. So it could just be a shell that you get with some commands that you've added, or it could be that you actually have a specialized program that reads these things. And you do this, you get some stuff, you give it some nonce that you've generated, the auditor has generated, the device signs it with signs it to prove it's really the right device, and that worked, come on, there we go. And you get something back, right? That's there. And you can send that. The result, it's an attestation. The result is an EAR, which you're going to use as an endorsement. And if you're thinking about, when I say auditor, if you're thinking about a CPA or someone from a big auditing company or something like that, then you're thinking exactly right. It's not going to be you and me. We don't have the right professional organization to do that kind of thing. It could be a government regulator, right? You could imagine that someone comes in from, I don't know, what in Canada would be CSE, and actually verifies that the things are where they want to go. And that's really it. Okay, so there's some little connection here to MUD and some of the stuff I did with MUD Query and IoT Ops, and they were percolating back and forth in my brain a little bit. And you could get the IDEV ID out of the device that way with the signature. You could pull out a MUD URL and you could do some other things, and that's kind of interesting. And you could do this in a physical way that does not involve the network. Okay, but what if you don't have a console port or it's inaccessible or something? Would you want to do this over Ethernet? And my first instinct is no, don't do that. That's so much more easily spoofable. We have entire working groups devoted towards, you know, making your Ethernet travel across the planet in super low latency such that, you know, you can build your L2 VPN. Okay. Would you want to do it over Ethernet with LLDP? Well, maybe if you really had to, but I would have preferred you not to, okay? And if you've ever looked at auditing profiles, there's this ISO 27001, which explains how to be an auditor, but doesn't say anything technical about that.
Next slide.
Yeah, is that the last slide? 8 of, I think there's one more slide. Slide clicker not clicking. I clicked it too many times. Maybe that literally is the last slide. Okay, that's it. That's the whole business. I've implemented half of it, and I don't see a big deal problem. As I said, you know, an app on a tablet or a phone, plus a couple of utilities that run on the router, and it's done. JP, something to say. 1 minute left.
All right. JP in the queue, and then we'll switch to the next presenter. Be ready.
Yeah, why don't you pull up the next slides already?
So ultimately, the guy that shows up at your box and get this evidence, and would that be a presenter?
The person, the auditor, yeah, that person could be a presenter. Yes, sure. Yeah, I hadn't thought about it, but you're absolutely right. That could be a presenter. And there's two choices, right? The presenter can push the results up to his cloud, and it can come back to the verifier the far way, or you can actually create a signed statement right there, an endorsement, and could send it back over the cable into the device, and then the device can present that as part of its verifier. Which way you want to go, there are pluses and minuses each way, and the document should probably outlet that in the security considerations. Okay, so you haven't put up the new slides yet, but you're going to.
Thank you very much. Next up, we have Osama on attested TLS, and you had a BOF this week on this as well.
Yeah, while the slide deck is loading, thanks a lot everyone for the support in the BOF. Great to see everyone contributing to it. And that's basically, oops, it's not working. Okay, so yeah, so it's, the expert BOF was pretty much successful in our opinion, and there are a few things that we need to change for the charter, namely, next one, please. As I have been talking about for the last few years, that the security goals are really, really important. That was also the outcome of the BOF, that, hey, this is not clear and this is not clear. That's something we need to work upon. And in particular, I have listed here a few things that I think are important. Namely, we need to definitely still maintain the TLS properties. And from remote attestation perspective, what we need is what I have listed here, like, I mean, integrity of the claims, any attestation claims, the freshness of the claims should be maintained, that any evidence that I send out, I should know that it's really fresh or at least recently generated. And then there is one property that we are currently looking into, namely where we need your help, is attestation credential refresh. There was a discussion also in the BOF that why exactly do we need this property, meaning that is there a real use case where we need attestation credential refresh? For instance, that the connection has been established. Now, if something is changing, why do we exactly, or what exactly is the use case where something is actually changing? And this is something up to discussion to have a real use case so that we can close this, Hank. I believe that's the last issue that's left over. Otherwise, I think pretty much everything is solved.
So I know that decentralized identifiers are a hot topic somehow in this IETF. But for example, if you have a remote resolver that you put your URI to, you really want to get the actual identity document back that you should get back. So in this interaction, I would want to know, is my resolver trustworthy? Does it do what it's intended to do, nothing else, and give me exactly the representation, the identity document back that I need for my DIT resolution? Again, DIT resolution is a weird topic, but that's an actual use case for ATLS.
But I don't understand how it is related to attestation credential refresh. By refresh, I mean that you have established a connection. So this was what I mean by concrete use case for attestation credential refresh. So
Okay.
of course, like now everything.
I was at the first bullet point. Maybe you passed on already. So I was with the first. Sorry, I was too late.
Okay,
too slow. Sorry.
So integrity and freshness, that's resolved. Like, and I think what we need is for attestation credential refresh.
No, there's an incredibly timely email that just landed in the attested TLS mailing list from Jonas that explain exactly that. So.
Okay, perfectly. Then it's also resolved. Thanks. Composition goals, when we combine these two things, we also need to maintain some composition goals, and these are basically that the remote attestation evidence should be bound to the underlying TLS connection, meaning that it's still the same server with which we establish the connection via identity. And in other words, that the evidence is generated by the same server that is authenticated. And it's really important. There was discussion, and actually a lot of discussion also in the BOF, and why binding is required and so on. So the simple point is that if we have an evidence from one entity and we have identity from another entity, that's kind of useless, because I'm saying that this server 1 has this state and server 2 has this identity. That should be really of the same thing if we are going to establish that connection or send over the secrets to that. And that's pretty much it. So what I am looking forward to some discussions is around what else is missing, or what other security goals we should be really worried about or we should care about, and particularly the security goals that we can really formalize, Henk. Okay. Okay, so any opinions in the room about what other security goals we should, more particularly what kind of security goals we should have for verification?
We are over time at this point. If you do have comments, you can make them. We can have discussion on the list. I don't think anyone is jumping up to be in the queue at the moment. So
Sure.
if you can think about this on your flight home.
Yeah, there is a separate mailing list. Please send it
On
to
the
that attested
TLS BOF
TLS.
list.
Yeah,
Thank you.
Thank you very much.
Thank you very much, Ned.
Thank you. It's been a great IETF.
Yes, we missed
We'll
you
see.
in person, so hopefully next time.
Hopefully next time. And yeah, we'll probably follow up with some interim meetings, I think, as people are walking out.
It's very noisy in here. I'm not able to hear you. Let's sync up after I get back from Spain.
Okay.
All right,
Sounds
great.
good.
Thank you so much. Take care.
Bye.